All right, I'm going to integrate this, but I'm going to show you two different ways. The first way is what I call the guessing method. Doesn't work for everybody. See if it works for you. In order to integrate something, that means we need to fill in the blank. The derivative of something has to equal the original integrand. So how would we do that? Well, I'm guessing that if we want to end up with an answer that is something to the 7th power, it might make sense if we guess that same thing to the 8th power. After all, when you take a derivative, you decrease the power by 1. It's a reasonable guess to think we'd have an 8th power as that function which we're taking the derivative of to get a 7th. Now, the first guess almost never works, but it gives you a good clue as to what your second guess should be. So I'm planning to fail here, but I'm going to learn something from my failure. Here goes the derivative. To take the derivative here, the 8 comes down, becomes a 7, and according to the chain rule, we multiply by the derivative of the inside. Simplifying this thing gives me 32 times 4x minus 3 to the 7th, which is close to what I wanted, but really instead of a 32 there, I would have rather had a 5. That gives me a good clue as to how I could make a second guess. I could just take this guess and put 5/32 in front of it. That should handle and adjust so that the derivative of this thing actually equals the thing I want. And it does, because when we take the derivative here, the 8 comes down, the power becomes 7. Chain rule says multiplying by the derivative of the inside, which is 4. And when you simplify all this, lo and behold, you do get that which we wanted to get. And therefore, we've now found the antiderivative or the integral of this function by guessing. Now, most students don't like the guessing process, and there's nothing wrong with the alternative, which right now is substitution. So substitution is where you let u equal something. I'm going to let it equal 4x minus 3. You want to usually let it equal something in the problem in such a way that it's going to simplify your problem. So if I take the differential of u, I get this. Remember, this is the same statement as the derivative of my guess is 4. And now what I can do is replace, looking at the original problem, I can replace 4x minus 3 with u. And now it's a simple integral to do here, except that I still have a mixture of letters. I've got u's and x's in my integral. In substitution, you have to completely convert over to u's. And so what I'm going to do here is I'm going to try to get rid of the dx. Now, if you look at my differential statement on the right, I have a 4 dx. So I thought of a great idea. I would do the multiply by 1 trick. Notice I've inserted a 1/4 times 4, which is of course 1. And as we know, multiplying by 1 doesn't change anything. But the clever of this choice of 1 is that I can now replace 4 times dx with du, thus completely converting this into a u-only integral. Doing a little simplifying and now applying the power rule gives me the answer. A little simplification beyond that, and I'm essentially done. But remember, you're never done when there's a u in your answer. If you're asked to do an antiderivative or integral of a function of x, you better answer as a function of x. No worries though, after all, u is 4x minus 3, and I can therefore replace u with 4x minus 3. And that completes this problem.